başlatıyoruz. İlk konuşmacımız The first presentation will be done by Mr. Biloke from Yaz University. Please, the stage is yours.
Thank you very much, Professor, and thanks a lot for attending the conference. It's the second day, and I will try to make my presentation as short as possible. Okay, everyone. My presentation is about anti-felting of wool fibers using a novel and green deep eutectic solvent. It's a work of my PhD student, who is Mr. Bustani, and my colleague, Dr. Fattahi from Yaz University. To make a long story very short, as you see, our environment is getting polluted by people's daily activities, especially from the industry, in any aspect: soils, water, air, everything is getting polluted. And we need to be careful about that, not to pollute it more, and use as clean as possible processes. And textile is one of the most polluting industries, as you all know. For tackling this problem, green chemistry came to the rescue. In green chemistry, there is a philosophy that says you need to replace all the polluting agents, all polluting processes, chemicals, with something which is not polluted, which is recyclable, and which is more efficient for the process or for the industry. So everything needs to be clean, and the process has been started for many years. One of the chemicals which is considered helpful in this criteria are ionic liquids. Ionic liquids are some solids which are liquids in the room temperature or above that. So they have attracted lots of attention, and one example is like this. So when they are alone, they are like solid, but when they are mixed, they are liquid. So why they are liquid? Because, in the lattice of normal ionic materials, the ionic force is very big because the anion and cations are getting very close to each other. But in ionic liquids, because there is an asymmetry and not symmetrical formation and structure, the anion and cations cannot get very close to each other in numbers, and because of that, they can be liquid. And deep eutectic solvents, or DES, are a group of ionic liquids which are liquid in normal temperature or low temperature that we usually like it, temperatures from close to room temperature. And as an example, you can see, for example, here, vitamin B, which is hydroxyethyl trimethyl ammonium chloride, as a cation, and as an ionic material, and on the other hand, something like urea. Both of them are solid. The melting point is very nice to see. Melting point of vitamin B is 302 degrees. Melting point of urea is 133. Both are solid. But when you mix them in a certain molar ratio, they become liquid, and the melting point is 12 degrees centigrade. This is very interesting. And that mixture does have very nice characteristics. For example, solubling many things and replacing some liquids which is harmful to the environment. In here, we sorted out some usage of the deep eutectic solvents or DESs in the textile industry in different years. As you see, I skipped them. And they have been used in organic chemistry for separation, for chromatography, in textile, in enzymatic reactions, as lubricants, nanomaterials, synthesis, nanocomposites, phase change materials, and nanofluidics. So there are lots of applications. And even in the mining industry, as you see, they can dissolve or separate some special ores from the soil they are taking. So in the mining industry, they can be used again. And in the textile industry, they can be used in different cases, but till now, only they've been used for extracting, for example, cellulose, for producing some kind of nanofibers for electrospinning, but not implemented in any aspects of textile industry. For example, in dyeing, they are not popular that much, but they will soon be very popular in all sectors of textile industry. And we want to address one of these. What I want to say is that we need to know wool. Wool is one of the natural fibers with a specific structures from the molecules, which is a protein, up to the fiber. It does have a complex structures, and we all, as a textile engineer, we know that. There is a problem with woolen fabrics, and its shrinkage when they are washed normally by water. This is the problem. And we cannot use wool exactly as it is for producing fabrics, because if we use it during the usage or washing, something like this happens. And to stop that, we need to do the anti-felting or shrink-proofing process. What causes shrinking the fabric is the scales on surface of the wool fiber, which does have a directional structure. And when adjacent fibers are rubbed to each other, the scales are moving into each other, clinging to each other, and the fabric is getting a different structure than previous one. So we call it felting process, and we need to remove the scales or to cover the scales for removing the behavior of getting into each other. So we need to remove the scales or cover it. There are different methods till now: acidic, alkaline, ultrasonic, enzymatic, ionic liquid, solvents, oxidation and reduction, potassium permanganate as oxidizing agent, laser, corona, coating, and the carbon dioxide in supercritical condition, sputtering. All of these are available. But what is the normal process of descaling or scale removal in the textile industry is using chlorine-containing chemicals, which is quite toxic. All of you know that. Sodium hypochlorite or sodium chloride is used for removing the scale from the surface of the wool. But it produces lots of chlorine-containing wastewater, which is highly toxic. All of you know. In here, we have started using the deep eutectic solvent instead of sodium hypochlorite, which is commercially used for anti-felting of wool fibers. As a this, we used choline chloride, vitamin B, B4, and urea. So these safe material come into each other, in contact with each other. Molar ratio is 2 to 1. So 1 part vitamin B4 and 2 part urea. And with that mixture, we could easily remove the scale of the wool fiber. In this photo, you will see that we took wool fiber, sorted out, then carded it. The carded fiber came out. We washed it by some kind of surfactants, then dried it. After that, we did the anti-felting process with 2 methods, one with hypochlorite and one with our DES. And the DES was optimized before being used. So I'm making everything very short. After process, we made some balls out of these washed fiber and treated fibers. And these balls with some amount of water was going into a rotodyer dyeing machine. So these are the cylinders for dyeing. We put any balls out of these fibers, treated or untreated, into that with water, and the machine started rotating at 40 degrees centigrade for 1 hour. Definitely by rotation, the felting process happens, and if the wool is not anti-felted or felt treated, the ball diameter would be less because of the felting process. And if it not happens, the diameter would remain the same as the ball we prepared before the rotation process. We check the surface of the fibers using microscope, SEM. And as you see, in different magnifications, you see here untreated control wool. There are the scales, obvious on the surface. This is hypochlorite treated, the scales are removed. And the DES treated, again, the same. So it's been removed very good from the surface of the fiber. And when we check the mean diameter of woolen balls after being rotated, in here, untreated wool fiber is 22 millimeter in diameter, hypochlorite treated 30 millimeter, and Relin or choline chloride urea, DES treated, is 29. So these two are very close to each other, Hypochlorite treated is a bit better, but it's still the same. There are not significant difference in terms of diameter. And if we calculate the shrinkage percentage on the fiber balls, we see this number, untreated wool balls has 32% shrinkage, while hypochlorite treated 8% and here 10%. Again, the same. And density of the wool ball again can be calculated, so showing similar activity for the hypochlorite treated and Relin DES treated. So in that case, we proved that we can easily use the Relin or a DES out of vitamin B4, which is safe, and urea, which is again safe for the environment, as a replacement to harmful hypochlorite chemicals. The result shows that the amount of the felting process we are getting out of the new DES technique is nearly the same as hypochlorite, while it is green and doesn't harm the environment. And what we will get on top of that? The price is nearly comparable or even cheaper. There is no waste. Why? Because you can recycle back Relin as many times as you want. And you saw that there is no water to be used. So the liquid goes with the wool fiber, and after that, dissolving some fiber into that. If you add some anti-solvents like acetones or alcohol, the fiber which has been dissolved will be precipitated, and after that you can remove this again and use it again and again. and the scales are removed, and on top of that, something that I've not presented in here because, you know, we've submitted a paper to the journal, so we couldn't publish everything in here at the same time. You know, the whiteness of the wool is very important. When you use hypochlorite, it's getting yellowish, but with the DS, it's not getting yellowish. So the whiteness is safe. On top of that, the breakage or tensile breakage of the fiber is getting low by hypochlorite. But using this DS, the strength of the treated sample is close to the untreated sample, which these two are very important on top of the possibility of using the green solvent for anti-felting process. Thank you so much, and hope you enjoyed it.
Thank you very much for this nice presentation. Is there any questions?
Please.
Thank you for your nice presentation.
You're welcome.
And I wonder about the effectiveness of the treatment material.
Yes.
Does the effect is permanent, or it is changed by washing cycles with the commercial detergents?
You know, definitely it is permanent because, you know, what causes felting? The scales, okay? And as long as you're removing the scales, so the surface of the fiber is quite smooth. So there is nothing to be stuck to each other. So it's going to be permanent, the same as all normally wool clothes we are wearing it. You're welcome.
Any more questions? I was going to ask the cost or feasibility of this process, but you already mentioned the
Thank you
conclusion
so
part, so thank you for the presentation.
You're welcome. It was a pleasure for me.
Bir sonraki sunumumuza geçelim. Canan Küçük bizimle.
Evet, merhaba, buradayım.
Merhaba Canan Hanım.
Merhaba.
Canan Küçük, Uludağ Üniversitesi Kimya Bölümü mezunu. Bursa Teknik Üniversitesi Biyokompozit Mühendisliğinde yüksek lisans yapmakta ve tez döneminde şu anda. Almax Yeşim Tekstil'de Ar-Ge Merkezi grup liderliği yapmakta olup eş zamanlı olup laboratuvar şefliği de yapmaktadır. 7 yıldır tekstil sektöründe çalışmaktadır. Sunuma başlayabilirsiniz Canan Hanım. Teşekkürler.
Çok teşekkürler. Sunumum gözüküyor mu acaba?
Evet, gözüküyor. Görebiliyoruz.
Öncelikle herkese merhaba. Organizasyonda emeği geçen herkese çok teşekkür ederim. Bugünkü projenin ismi rotasyon baskı prosesinde atıl kalan boyalı patların değerlendirilerek sıfır atık odaklı baskı geliştirilmesi. Size çok kısa firmamızdan bahsetmek istiyorum. Üretimine 1983 yılında başlayan Yeşim'in günlük üretim kapasitesi 115 ton örme, 125 ton boyama, 250 bin adet parça baskı, 100 bin metraj baskı, 250 bin adet giyim, 100 bin adet de ev tekstilidir. Yeşim Grup, Nike, Zara, Under Armour, Tommy, Kappa gibi müşterilere üretim yapmaktadır. Yeşim Grup çatısı altında bir Ar-Ge merkezimiz bulunuyor. Ar-Ge merkezimiz 4 çatı altında projelerini gerçekleştiriyor. Bunlar kumaş inovasyon, akıllı tekstil ve nanoteknoloji, sürdürülebilirlik ve dijitalleşme. Bugün sizinle paylaşacağım proje sürdürülebilirlik çatısı altında gerçekleştirildi. İçerik olarak giriş, proje özeti, materyal ve yöntem, deneysel sonuçlar, genel sonuçlar, sonraki çalışmalar için öneriler ve referanslar olarak sunumu kapatacağım. Giriş kısmında birazcık su kirliliğinden bahsetmek istiyorum. Çünkü tekstil sektöründe biliyorsunuz sektörler arasında çok fazla kirliliğe sebep olan bir endüstri. Tekstil üretiminde yılda yaklaşık 100 milyar metreküp su kullanılıyor. Bu su tüketiminin 2030 yılında 1500 milyar metreküpe ulaşması bekleniyor. 2050 yılında ise bu toplam giyim arzının bugünkünün 3 katı olması öngörülüyor. G20 ülkeleri genelinde baktığımızda tekstil endüstrisindeki su kirliliğinde Türkiye ilk sırada yer alıyor. Ve 2050 yılında öngörülen tahminlerde 3 katı olduğunda bu kirliliğin daha da artması öngörülmektedir. Çevre bilincine sahip olan tüketici ve üreticiler çevreye daha az zarar veren ürünlere yöneliyor. Tüm dünyada sıfır atık uygulama çalışmaları hız kazanıyor. Tekstil sektörü de kaynakların daha verimli kullanılması için sürdürülebilir iş modelleri tasarlıyor ve bu doğrultuda atık geri dönüşümü ve atık miktarını azaltma projelerine odaklanıyor. Tekstil sektöründe en yaygın olarak kullanılan baskı yöntemi %65 kullanım oranı ile rotasyon baskıdır. Bu bilgiler doğrultusunda rotasyon baskıdaki atıklara odaklanarak proje çalışmasını başlattık. Projenin özetinde ise sıfır atık prensibiyle çevre dostu bir üretim anlayışıyla projemizi gerçekleştirdik. Bu çalışmada kaynaklarımızı verimli kullanarak tüketime ve atık oluşumunun azaltılması için rotasyon baskı projesinde atıl olarak kalan boyalı patların tekrar kullanılması amaçlandı. Çalışma kapsamında boyalı atıl patlar toplandı ve patların bozulma süreleri 14 gün gözlemlendi. Karıştırılarak toplanan boyalı atıl patlar kumaşa uygulandı ve atıl olmayan patlarla birlikte basılan kumaşlarla aynı test metotlarında test edildi ve karşılaştırıldı. Malzeme ve yöntemde ise iki farklı altyapı malzemesi kullandık. Biz %100 pamuk süpren ve %1 pamuk, %91 pamuk, %9 polyester karışımlı 3 çiftlik. İki tane kullanmamızın amacı reaktif pigment baskı ile reaktif baskı patıyla pigment baskı patının farklı kumaş elyaf cinslerinde kullanılıyor olmasıydı. Reaktif daha çok selülozik yapılı kumaşlar uygun olurken pigment ise karışık elyaflar için uygun oluyor. Yöntemde ise aşağıda gördüğünüz rotasyon baskı şablonu var. Bu şablona boyalar yükleniyor ve basma gerçekleşiyor. Şablonun içindeki boyalar buradaki varillere toplanıyor. Şablonun içine verilen atıl kalan boyalar da tekrardan bu bidona yerleştiriliyor. Baskı mutfağında 14 gün kadar varillerde ayrı ayrı toplanıyor. Sonra tekrardan şablon verilerek basılıyor. Çalışma kapsamında normal boyalı baskı patları ve atıl olan patlar ile baskı çalışmaları yapılıyor ve bunlar karşılaştırılıyor. Yapılan karşılaştırma sonucunda da test sonuçları arasında ciddi bir fark olmadığı gözlemleniyor. Buradaki testler haslık testleri. Haslık testleri yapmamızın amacı aslında müşterilerimizin en kritik noktaları yıkama hassılığı, su hassılığı, ter hassılığı, sürtme hassılığı, ışık hassılığı ve pH değerleri. Bunlardan geçiyorsa zaten ürünümüz okeyli oluyor bizim için. Burada da baktığımız zaman aslında atıl olan ve atıl olmayan patlar arasında yarım puanlık bir fark bulunuyor. Yarım puanlık bir fark da bizim için ciddi bir fark olmadığı için bu çalışmayı olumlu olarak tamamladık. Genel sonuçlara baktığımızda çalışma sonucunda reaktif ve pigment baskı patlarının atıl olan patın tekrar kullanılmasında herhangi bir sorun olmadığı gözlemlendi. Boyalı atıl patların 14 günlük bozulmaları takip edildi ve bozulma gerçekleşmediği gözlemlendi. Çalışmanın kazanımı olarak atık oluşumunu engelleyerek rotasyon baskı prosesinin atık su yükü üzerine bıraktığı kimyasal yük azaltıldı. Çevreci bir üretim metodolojisi geliştirildi. Atıl kalan baskı patlarının desen ve baskı prosesleriyle tekrar kullanılabilmesi sağlandı ve bu çalışmada aylık 125 kilogram işlem sonrası kalan pat ile kimyasal kullanımı azaltılmış oldu. Sonraki çalışma için öneriler, reaktif baskı patı ve pigment baskı patı olarak her bir patın bozulma süresi belirlenebilir. Biz 14 gün olarak sınırlandırdık ama daha fazla da olabilir. İkinci bir öneri, siparişe göre baskı patının rengi değişiyor. Bununla birlikte sabit renk çalışması yapılabilir. Bizim bir sonraki çalışmamızda koyu renkler baz alınmıştı. Kahverengi, lacivert ve siyah olarak belli oranlarda boyar madde ekleyip sabit renk elde ettik. Atık su yükünün hesaplanarak belirlenmesi de bir sonraki öneriler olabilir diye düşündük. Proje takımımız ben, Tuğçe Hanım ve Filiz Hanım'dan oluşmaktadır. Bu çalışma Türkiye Sanayi ve Teknoloji Bakanlığı'nın desteklediği öz kaynak projesiyle tamamlanmıştır. Referanslarımız. Dinlediğiniz için çok teşekkürler. Sorunuz varsa alabilirim.
Teşekkür ederiz Canan Hanım sunumunuz için. Soru var mı salondan? Yok zannediyorum. Çok teşekkür ederiz sunumunuz için.
Ben teşekkür ederim.
The closing presentation of this session, before the closing session of the symposium, is again done by Mr. Bidoki. This is the stage
Thank you so much. Thanks a lot. I think. Yes, everyone. Thank you so much again. I think I'm the record winner of the conference mugs because this is my 5th presentation here. Okay. Yeah. So I'm very happy for that. Again, I try to make this as short as possible. Our presentation is using 100% recycled water for dyeing and wet processing of cellulosic fabrics in Akbaşlar Textile Company. You know Akbaşlar Company, it is located in Bursa and it is very big, producing 1 million meters of cotton and mixed fabrics as dyed and 1.5 million meters of fabrics per month as printed fabrics. So they are using lots of water. As I heard, more than 3,000 cubic meters per day. So 3 million liters per day is the water consumption, and it goes to the wastewater. They are very genius people. They are returning it back and reuse it mainly, for example, if it's not very dark in color, they will return it back and use it in some other processes, but it is not very easy to handle usually. So we presented them with a process to remove the color from the wastewater and use it again. And as you know, water is used a lot in the textile industry, and you're welcome.
The Zoom connection
is lost. Okay.
Because I think we don't share the secret. Just let me check. İnal hocam, sıkıntı var mı?
Şu an hocam göremiyoruz. Ha, şu an geldi hocam. Evet.
Tamam, tamamdır hocam.
Çok teşekkür. Thanks a lot. Now the Zoom connection is on, and because my friend from Akbaşlar is attending online, so I should say hello to all of them and continue. So Akbaşlar is reusing some water, but not recycling that, and mainly discharging wastewater to a wastewater treatment plant. So Textile is using lots of water and producing lots of wastewater. But with this method, we are taking water out of our reach and make it polluted and release it to the environment. So there should be an end and a stop to that. And definitely the environmental regulation and governmental laws are above that. And definitely one day they will stop us from using water, the same as some areas in Turkey. Nowadays, I'm hearing that they are not allowing people to take water from the river or to discharge anything outside their factory. So the rules is in place now in some areas, not everywhere, and they have to, find a solution. And there are lots of water used in the textile industry, as you know, for treatment, but there is not enough water. These are the water sources we can use, but there is not enough water nowadays to use for textile industry because we need to save the water for feeding people, animals, producing foods. Normal practice is that taking water from water sources, then make wastewater, treat wastewater in a very big, usually very costly treatment plants, and then discharge it to the environment. And with this process, we are always continuously consuming water and producing wastewater, which is toxic. So the environment is getting polluted and the ecology is changing in the negative direction day by day. So what is the final answer? Recycling. For example, for the companies located in those areas that I mentioned, they are not allowed to take water and to discharge the wastewater. The only solution for them is recycling. So the government is saying you are producing wastewater, so now you are responsible for reusing it. You cannot do anything else. So they need to recycle and then reuse it in their actual process. And if there is a good recycling process, you can easily get up to 80% of the water recycled back to the factory. So it's worth looking at it and find a good solution. So they have to reduce water consumption first, then reuse it. And for reuse, they have to recycle it. This is a 3R philosophy in the production. In every production, this is the common practice from now on. But for treating wastewater, there are different ways: biological, electrochemical, oxidation, photocatalytic, membrane, microbial degradation. Everything is possible. And the quality of water for discharge should be to some extent high, because if there is any pollutant damaging the environment, you are not allowed to discharge it. But for recycling, you don't need to remove all the pollutants because you need to use it for the inside your factory. And for example, you need to make sure that the product is not leaving the factory with any pollutant on that. But the water is used in a closed cycle, no touching the environment. And the process available are biological systems mainly, or biological and filtration, RO processes or nanofiltration, but the filtration processes needs constant quality of wastewater, which is not normally available in the factory. Every day, they are changing the quality because the customer are ordering different products, so we have to use different chemicals. So what we should do for these technologies? The technologies available for us for recycling, but it is very expensive. Like this, for example, for 400 cubic meter, $450,000, which is not affordable by every factory. So it needs to be lower in price. What we presented them for 1,500 cubic meters per day, half of their wastewater. They said 50% recycling would be enough for us. Okay, so this is the proposed system: equalizing tank, then the reaction take place here, then some discoloration by oxidation method would happen here, and after that the water, recycled water, would be stored for use. And instead of hard water, they can use the same piping for the recycled water, so there is no need for extra piping in the factory. We previously used the recycled water for dispersed dyeing, and it was working very good. And in here, you know, fresh water, recycled water for dispersed dyeing, these are nearly, not all of them dark, you know, they are light colors, some of them. And you don't see that much difference between the recycled water and fresh water. And I've got a factory in Iran. They told me that for 6 months, they keep recycling the wastewater into their factory. It was polyester dyeing, which is easier to handle. But in Akbashlar, you know, they sent me in three times wastewater. The last time it was around 60 liters. I recycled it in 2 formulas. Call it recycle 1 and recycle 2. And ask them to use it in your processes. Usually we recommend to use it for washing. For example, I said that they are producing 1.5 million square meter of printed fabric. For printing, you know, you just need washing. So lots of water can be used in the washing process or in the dyeing. When you are using reactive dyes, once you dye it, but 10 times you wash it after dyeing. And there are lots of wastewater, which is some of them very colorful, some of them less in that. So I told them, okay, to make sure, use it in the dyeing. They used it and sent me the results. The wastewater, you know, some parameters of the wastewater is here. Because usually we don't care about the parameters. Usually we control the pH and hardness, not COD. BOD is not important because they don't have very big effect on the dyeing process. So COD, BOD before treatment are like these, 700 and 100. And after process is R1 and R2. As you see, COD from 700 to 200. It's not that low, but if it's reusable, it's okay. And as long as it doesn't have any negative effect. They used it on viscose fabrics with 7 different dye recipe, exactly the same as they are using for fresh water. In number 1, as you see, they dyed it, any of these 7 recipe using fresh water. Then washed it with fresh water, then rinse it with fresh water, and then neutralize it with fresh water. In number 2 and 3, they dyed it by recycled number 1 water. Then in number 2, washed, rinsed, and neutralized using wastewater number 1. And in number 3, washed, rinsed, and neutralized using fresh water. So the washing is different, fresh water and wastewater. And number 4 and 5 was dyed with recycled water number 2. And in number 4, they washed, rinsed, and neutralized using the wastewater number 2, number 5 with fresh water. And then they measured the color triostimulus values, and from them, they extracted the delta E or color difference. As you see here, under different light sources, number 2, 3, 4, 5, the delta E is listed in this table. And as you know, if it is less than 1, there is no significant or observable color difference between the dyed sample and the original sample. What was original? Sample 1, which was used and dyed with fresh water. So as you see under D65 with number 2, which was dyed and then washed with recycled water, there is no color difference. Only under TL84, there is a bit of color difference, which is not that much. But 4 and 5, which was used by the second style recycled water, does have some changes. It's not that much, but it's still, you know, a bit. Why I'm telling it's not that much? Because, you know, I asked them to repeat your experiment twice. How? For example, a simple recipe, you take it, dye 1 sample, exactly do the same in another sample. Nothing is changed. Fresh water, dye, auxiliary, everything. So the difference would be the accuracy of the examiner or the machine or anything available. And out of that, you know, we saw around 0.4 unit of color difference. So it shows that there are some changes in the machinery, in the process. And because of that, I'm telling that, for example, 1.02 is not showing that exactly there is a color difference. But we can conclude that the process can deliver us some result which is not color different from the freshwater dyed samples. And the system, you know, would be something like this. If it plays, I have to. Look, it is something like this. So it is highly colored wastewater. Before this place, we treated it with some special chemicals. Then it goes to the oxidation process through this pipe. This is the oxidation unit. And it is for 400 cubic meters. So 1,500 would be 4 times bigger, not 4 times bigger, at least 2 times bigger than this in size. And this is the water that was very dark, and this is very light coming out of the system. So this was the proposal that we put forward. And you know, what is the only discharge from the factory? It's only the sludge. And the sludge would be in a form of a cake, a compressed cake. As you see, it is not that much voluminous. It is manageable and easily can be separated from the filter press. It's not playing again, so I have to play it from here. Just by shaking the filter press plates, you know, the sludge comes off. It is compact, more than 50% solid, and sometimes it's getting up to 70% solid, which is very good, and it is manageable. But definitely it is a chemical waste and needs to be landfilled, so needs to be discharged according to the governmental regulations. With this technology, they use less fresh water. They can produce limitless. There is no restriction for the production. They can receive some bonus from the government for the electricity usage if they are recycling back the water. And for the customers, you know, European customers like Zara, Marks and Spencer, they buy more from suppliers who are recycling their water and caring about the environment. And on top of that, you know, because if they had to use the RO system or filters, there is a discharge from that. So if they don't recycle, they have to soften water. And for softening water, there is a salty discharge. And the discharge is another problem. So if they recycle, because they can use it directly into their line, so they don't need to use those softening processes. And on top of them, saving water resources for everybody and saving the environment again. So we concluded that the system can work, is very promising for reducing the water consumption in the textile dyeing and wet processing. And when we know that it is working, it is getting very hard not to use that, especially for the washing. So it's working, so we have to use that. Maybe this technique or any other technique, we have to use it because the restrictions are in place and getting closer and closer to us. Recycled water can be used in the dyeing process. It can be perfectly used for all pre and after washing procedures. And to reduce up to 90% of water consumption, they can use the system or any other system which recycles back the water. I want to thank Aquashlar company for doing this test. And at the end of the presentation, I want to tell you again that wastewater recycling and reuse is not only a system to purchase, it's a culture to follow. So you need to buy something, but more importantly, you need to be careful about the environment. You need to care about that to be successful. So you are the one who plans to use wastewater, and this is the main thing. If you decide, definitely you'll be successful. Thank you so much and have a great day. Thank you.
For this interesting presentation.
You're welcome, sir.
Is there any questions?
Yes. type of dye were you using during this?
You know, because it was viscous or reactive dyes they used it, but the system works for reactive, disperse, wet, and direct dyes, which is all kind, and even acidic dyes, cationic dyes will have the same system. So every kind of dye can be treated.
So the system can be used for multiple different types of dye.
Exactly, you know, and yeah, and this is the simplicity of that. You know, if you, for example, for RO filters, you will tell them, do not change the quality of the wastewater. So you should be careful about what you are doing in the production hall. But in here, you tell them whatever you like, do it. We don't look at there. Only look at these, okay? And what comes out is gonna work for the washing, dyeing. And what we tell them is that, look, for the dyeing, use the fresh water, but for washing, use the recycled wastewater. And because every day 5% of water is evaporated, you need to feed 5% fresh water. And in that case, you know, the water for the dyeing is supplied through this soft water, and there is no problem at all.
Also, you said you use
Yes.
Are there any side effects to using this symbol due to the fact that it's being used from clothing?
No, it's not based on chlorine at all.
I mean, clothing.
Oh, clothing, yeah. You know, till now, out of 7 years of industrial experience, it's more than that installation, but it is 7 years of industrial experience, and we haven't seen anything. And on top of that, we tell people that the final washing should be with fresh water. Okay, so the final washing and the dyeing process with fresh water, the rest with recycled water. In that case, you're going to make sure there is nothing in that. And because the recycled water does not have something which is dangerous, so it's very easily can be used again. You're welcome, sir. Thank you. Thank you very much.
Is there any other questions? Thank you again.
You're welcome, sir.
So this was the last presentation of this session. So we will have a closing session, like in a couple of minutes, I believe. It's starting now. So thank you very much. See you at the next symposium. In Yalova, our place. Yeah.
You are host.
İnal hocam,
How are you?
kolay gelsin.
Thank you. Thank you.
Görüşürüz.
Görüşürüz hocam.